And also I would like to say thank you to my partnership organizer, Dr. Iwan and Technology Muiz, for organizing this joint lecture today. I feel honored to give lecture for you all today, and this is the topic I will share with you on the earthquake source, seismicity, and introduction to Malaysia Annex. So here is will be our contents overview for 2 hours lecture today. There will be separate in this section. So the first section I will explain on the earthquake phenomenon, on the definition of earthquake, what that creates an earthquake, and cause of the earthquake to our structure and people. And this is will explain based on the tectonics, the types of fault, as well as the types of seismic wave. And then on the second section, we will go to see the earthquake database. This consists of the collection of earthquake catalog. I will share some of how to collect this earthquake catalog. We will try some example on where we can find the earthquake catalog. And we will go to also the definition of magnitude. And then on the seismicity for our site of interest. And then the last section will be on the Malaysia Annex. So I will explain in general the method of producing the seismic hazard and show the map that being produced for Malaysia region. And we will also, I will also teach you on how to read the maps for Malaysia hazard maps. So on the first section, on the earthquake phenomenon. So we would like to know what is the definition of earthquake. Okay, what is earthquake? So this is a phenomenon that results from the sudden release of stored energy in the earth crust that creates the seismic wave, the vibration. Okay, the sudden release, and then it releases energy in terms of the vibration or seismic wave. And another definition, you can also say that this is caused by the tectonic plates getting stuck and putting a strain on the ground. So it's released the energy, it's stuck from one point and it's released energy and it moves towards the ground, okay, the surface ground of the earth. And where the location of earthquake occurs. So most of the earthquake occur in our lithosphere of the earth. So this lithosphere is the outer level of the earth, so we call as a lithosphere. So most of the earthquake will occur within this area. Okay, and why we need to learn earthquake? So why Malaysia previously are stable, we have not experienced earthquake, but suddenly in 2004 it's been actively said that earthquake in Malaysia is categorized as low to moderate seismicity. So why we need to learn earthquake? Okay, so from the collection of the earthquake or for Malaysia region, this is the statistic that has been collected from the 1900 until 2020. So the compilation is collected from the magnitude 3 and until magnitude of 7. So we can see the yellow color here is for magnitude 3 to 4. Light blue is for magnitude 4 to 5, and the dark blue here is for 5 to 6 magnitude, and the red color one is from 6 to 7 magnitude. So this is Malaysia earthquake patterns that we received from 1900, and you can see that the frequency of magnitude 4, okay, magnitude 4 is the light blue. Okay, so we can see the pattern has been slightly increasing starting from the year of 1950. So why is this increasing? Is it because of number of earthquakes are increased by the fault line is already active? So the quotes from the United States Geological Sign, USGS, temporary increase or decrease in seismicity is part of the normal fluctuation of earthquake statistic. So neither an increase or decrease worldwide is positive indication that will receive in the future. Okay, because of we have already experienced some of the earthquake activity across Malaysia region. Earthquake increasing in recent years. Okay, if you can see the pattern from 1980 until 2010. Okay, so we can see that's increasing. But because there are many seismic instruments, and they are able to record more earthquakes. Therefore, we have received more earthquakes starting from the 1980s. Because technologies is become advanced nowadays, so that's why we actually experience this earthquake from 1900. Because no instrument from 1900, so we are not able to have that good database of earthquake statistics. And from this statistic, our country is already experienced, if you can see the red color, of magnitude 6, okay, starting from 1900, 1920, 1950, 1970 until 2010. So we have received 5 of major earthquake occurred in our country. So we already experienced that. And the violent shaking of 2015 in Ranau incident is an example of how 6 magnitude to the people. So if you can see from these 3 figures here that the ceilings falling down, the column has been damaged, and the critically damaged on the column for below right figures. So we can see that how that 6 magnitude creates and damage all this property. So the main shock, this main shock that produced in Ranau earthquake lasted for 30 seconds. It's created by the normal fault, okay, normal fault that create this earthquake 6 magnitude at a depth of 10 kilometers. And after 6, we also receive about 90 aftershock, okay, a 90 aftershock that can be felt for 500 kilometer radius. Brunei also can felt, from Miri, Sarawak also can felt this shaking. So the aftershock we can, from the studies, is ranging from magnitude of 1.6 to 5.2. Okay. So not only that Ranau cases, we actually has earthquake in Sabah. Okay, this is example earthquake in Sabah has produced some damaging to the structure. For example, in 1976, the magnitude carried 5.8. Location in Lahad Datu, we can see that walls of the ground floor of the new office complex Lahad Datu were badly damaged. Okay, no, there are no picture here, so only this stated that they are badly damaged. And cracks appear in other buildings, including the telecom building and low-cost houses. And another in the year of 1983, magnitude of 5.1 in Tawau, and we can see the cracks appear in general hospitals and the residence office. And then the following year, 1991, with magnitude 5.1 in Ranau, okay, we can see the school suffered a structure damage, brick walls collapsed and crack produced. It also produced a landslide in the area. And in 2008, in Kuna, the earthquake have caused minor cracks on the floor and walls of the supermarket and minor damage to the concrete base of an oil palm storage. And then the 2015, the recent biggest earthquake, 6 magnitude, it's affect 23 buildings of schools with 6 different districts, including the mosque, and serious damage occurred to the hostels, a rest house near to the summit of Mount Kinabalu. And then in 2018, just 3 years ago, with magnitude 5.2, we can see a minor damage on the climbing routes, in the climbing of the Mount Kinabalu, but no damage on the structure. Okay, so why we are considered as a low to moderate earthquake region? So because we receive a local earthquake, that produced from our Malaysia, Semenanjung, Sabah and Sarawak, has its own local earthquake. And this local earthquake is from magnitude 2 until 6.5. And we also situated in Eurasian plate. Eurasian plate is a stable plate, but we actually affect from the 2 conjunction plate along the Indo-Australian on the south and Philippines plates on the west. So these two plates is actually producing very active earthquake activities. And then we can see an increase in number of low earthquake, and we also already experienced a large magnitude of earthquake. So that's why we are considered as a low to moderate earthquake region. Okay, and why we have this earthquake happen in our area? Okay, what's actually producing this shaking in our area? Okay, we have to look in other bigger picture. Okay, bigger picture. So we know that our Earth is created by plate boundaries and plate tectonic. Okay, plate tectonics that are movement. So for example, we have plate boundaries. Plate boundaries, if you see on top left figure, is the when Earth's tectonic plates grain past one in another. So enormous amounts of energy can be released in the form of earthquake. And then these boundaries are usually well defined and plotted on map. Okay, for example, in this figure, at a reasonable, accurate location. And plate boundaries are important. We need to know about the plate boundaries on our area because they are often associated with earthquakes and volcanoes. So they said that the plate boundaries is in terms of ring of fire. So ring of fire is actually where the location of big earthquake and volcanoes occur. So there are three types of plate boundaries we can see on the red color. Red color is known as a convergent. And white color from the map is a divergent. If you can see, maybe you cannot see from your slide, but for white color from this figure is called as a divergent. And the orange color is transformed plate boundary. Okay, we move on to theory explaining the structure of crust and slowly over the underlying mantle. So plate tectonics is the theory of plate tectonics, explain process in the geosphere that are fueled by the Earth's internal heat. So we have so it actually hot. So this movement, internal heat will have to go up. So it will go to colder colder area. So goes to heat to cold area. So it circulate. Okay, circulate from the mantle to the earth crust. So that's why our plate tectonics are moving. So it's under to stable that earth. So that's why the movement of internal is actually moving from mantle below to the top of the earth plate tectonic. Okay. So in plate tectonic, it will create this, for example, subduction zone. Okay, subduction zone, and also this producing the convergent, divergent, as well as the transform. So because it's moving, that's why it creates a bigger earthquake because the plates is quite big. Okay, if it's move and then release a sudden energy, that's why we receive this big earthquake. Okay, so this is the three types of plate boundaries. Okay, if we have divergent types of plate boundaries, so the divergent is in motion of spreading, so it's move away. So our plate tectonic, one side to other side is move away to each other. So it's create a spreading of the plate. So the effect is constructive, so it will create the oceanic lithosphere created. So we can see there are some biggest line on the sea floor, so we call as a divergent plate boundaries. It creates the ridge and reef, and it can has the volcanic activity for the divergent types of plate boundaries. Okay, what about convergence? So convergence is moving face to each other. So these two plates are facing to each other and give motion to that. It creates one will go up and one will go down. So most of these cases we can see on the case of subduction zone. So subduction zone, we have one plate goes down to the other above plate. So that the above plate is quite strong compared to the one plate that moves towards below to the upper layer of the plate. So the effect of these convergent plate boundaries is destructive, means the oceanic lithosphere will be destroyed. Okay, so it's moving down, so it creates something like dua lapis, two layer of the Earth crust. And topography, you can see the trench pattern on the sea floor. So this is actually categorized as convergent plate boundaries. And is it can produce the volcanic activity? Yes, it will produce volcanic activities. And the third types of plate boundary is transform plate boundaries. So if this transform is moving in horizontal together. So it's moving one passing to each other. So it's more like a lateral spreading, and it's conservative. So it lithosphere neither created or destroyed. And no major effect will be created from these transform plate boundaries, and no volcanic activities can be found in the area of transform plate boundaries. Okay, on the fault. So what is fault? Fault is a rupture in the Earth's crust. So what is the plate boundaries and suddenly fault? Okay, there are two terms different. Okay, different fault plate tectonic is different, fault features is different. The fault is formed in the Earth's crust as a brittle response to stress. So it's a create small line on the Earth crust. Okay, and the movement of the tectonic plates provide the stress and rocks or the surface break. Okay, in response to this. So fault have no particular length scale. So a fault is a planar fracture in rocks across which there have been displacement. So there have been displacement as a result of movement. So even plate tectonic is movement. So it creates this small line on the Earth's surface. So we call this small line is a fault features on the surface of the Earth. So what we have in Sabah also fault, we have a small cracks. Okay, this cracks is actually the fault. And if you see the fault features here, if we see on the Google map, okay, from I think geologists are more expert on this, we can see that one straight line is fault, and then below the fault line they have, if we have an seismic activity, so it produces an earthquake, so we call it as the focus or hypocenter. So this focus hypocenter is the point on the fault where the rupture occurs and the location from which the released energy from the focus, so we call it as a seismic wave. And the epicenter here is the point of the Earth's surface that is directly above the focus. And the seismic wave is the transmit energy released by an earthquake. So this is energy or vibration that we felt if there is an earthquake. So we call this as a seismic wave. So there are three types of fault. Commonly, there are three known types of fault. The first two is deep sleep, which is called as a normal fault, and categorized deep sleep called as a repose fault. And we also have the third types of fault, which we call as a stress sleep fault. So what is a deep sleep fault? Deep sleep of a normal fault. Some technical error. Okay, so here we call as a deep sleep, categorized as a normal fault. So normal fault is one side of the fault moves downward and with respect to each other. So if you can see in the video here, we can see that one side of fault will move downward. So this we call as a normal fault. And why we say it's foot wall, why we say this as a hanging wall. So if you see that pattern pyramid here like a shoe, right? Shoe. So macam our foot. So the shape of foot we call as a foot wall. Hanging wall because it's shaped like hanging your shoes upside down. So we call it as a hanging wall. So in case of a normal fault, because it goes down respect to each other, it will create extension of the line of the fault. So from with before will extend some certain length, it will create this normal fault. So for example, in the site field work, we can see that the line is not in line with each other, right? We can see that this pattern we call this so we call it. And then the second one is blocks of rocks are for compression. So one here we call hanging wall goes so most of the earthquake that produced by the reverse earthquake is from the major earthquake because it creates more energy to create this reverse fault. Okay, so big earthquake mostly created by this reverse fault. So if you can see that from the reverse fault is due to the compression. Okay, the length is shortening. Okay, the length of the fault is shortening. So we can see here, this is the fault wall. So here it goes up. Okay, from this line and it goes up to this line. So we call this as a type slip of a reverse fault. And then the third type is strike slip fault. Strike slip fault is passing the blocks, two blocks are passing each other horizontally. So like that. And it will create shear on the passing blocks, one blocks to each to other blocks. So we call this as a strike flow. So it moves horizontally, either from right-handed or left-handed. So in railway tracks, we can see that this is going to the other direction. So we call this, we can see below this railway station, railway tracks is actually built on top this strike slip fault. Okay. All right, what is the other effect from the earthquake? This is one example of primary effect from the earthquake, which is on the liquefaction. Okay, the liquefaction we can observe in our recent case of Palu in 2018, where the earthquake with 7.3, okay, 7.5 magnitudes, and it creates this major soil liquefaction. And this lead to mud flow in which many buildings become submerged, okay, submerged below the ground, causing hundreds deaths and many more missing. So it happens where there are people in that house and suddenly the soil loses its strength and creates this soil liquefaction by the earthquake. And this case of Palu earthquake is considered the largest in the world and was deemed as rare. A liquefaction that this big. We are not experienced this previously, but Palu was the largest case that we have on the liquefaction area. So we can see the graphic just now with the buildings all suddenly goes submerged. Okay. So the liquefaction is the mixing of sand or soil and on groundwater during the shaking or moderate and strong earthquake. And then what is the primary effect of the earthquake? Okay, this is tsunami. Okay, tsunami, one of the primary effect of the earthquake. So it's actually we in the case of popular one, actually in 2004. In 2004, the magnitude produced by the sea floor subduction is 9.3. It's quite big. And the wave is actually up to 30 meters high once heading the inland after being created by the underwater seismic activity offshore. And for the Aceh 2004 case, it killed more than 200,000 people in 14 countries. So it affected many being affected by this tsunami, okay, because of the 9.3 magnitude of earthquake under the sea floor. And it is considered one of the deadliest in history of tsunami event. So this is the pattern. If we have a sea floor spreading from below the sea floor, so it's actually create this seismic wave, okay, the shaking on the sea, okay, the sea water. So the sea water will take the energy from the earthquake below the sea floor. Thus it create this big wave when it goes to the seaside. And then we also received the Sulawesi cases also, yeah, the liquefaction, and this is Sulawesi also received the 2018 earthquake that producing this tsunami also. Okay, and then more than 4,000 people deaths to this Sulawesi earthquake incidents. So that finish on the section 1. So means that we already covered based on the earthquake terminology. For example, the earthquake is the sudden shaking of the earth's surface, and the location of the earthquake producing that from the hypocenter focus is called as the point below the earth's surface where the earthquake begins. And then the epicenter is the point on the earth's surface directly above the hypocenter. And what is fault? Fault is the cracks in the earth's surface. And what is tectonic plates? Is the large section of the earth's crust. And the crust is the outer layer of the earth where earthquakes occur. If you go through this earthquake terminology, means that you understand the nature of earthquake. All right. You guys all with me?
Yes.
Yes.
Okay.
Yes, Doctor.
Yes,
All right.
Doctor.
Thank you for the response. Okay, so we move to the definition on the earthquake magnitude plan. Sorry, ada typo there. A bit typo, earthquake magnitude. So what is earthquake magnitude? Okay, we have know that terminology of earthquake that producing this earthquake shaking from the focus of fault. So we measure, this is how we measure the earthquake force. Okay, this is one of the measurement. How big is the earthquake? So we call it as the earthquake magnitude. So how can we measure the earthquake magnitude? So this is based on the measurement of the maximum motion recorded by the seismograph. Okay, seismograph we can get from our seismic station. Okay, I will explain on that later on. So in a research study on the earthquake on measurement, so it actually has 4 types of magnitude that most commonly used are local magnitude. Okay, our Malaysia region, we use this ML, okay, local magnitude. So, or this referred as a Richter magnitude, okay, Richter scale, Richter magnitude. So this is what the terms that Malaysia use. Okay, and then we have another surface wave magnitude or MS. This is actually we measure from the 20-second surface wave magnitude. So 20 seconds, so about 20 seconds, so we measure the surface wave magnitude. And then the third type is the body wave magnitude. So this is we call as the short period P wave magnitude. And then lastly is the universal moment magnitude. So in seismology engineering, earthquake engineering, or geotechnical engineering, we usually use the universal types of magnitude, which is the moment magnitude. Means that we need to convert all other types of magnitude into one moment magnitude. So here is a picture about the seismic station. Okay, we install area that producing the earthquake. So Ranau has a few seismic station. Our Kita Kinabalu, Semenanjung also has a few seismic station. So the first seismic station being installed by Malaysian Meteorology Department is in 2004 and have been upgraded and 8 more in 2015 or 16. So you can see that if you can see this figure. So if we have earthquake fault line here, right, and then suddenly it stopped, okay, and it produced this earthquake. So seismic wave release its energy, okay, moving away from its focus. So this is seismic wave. So this is seismic wave will be measured by the seismic stations. So this seismic station will able to read how big is the magnitude coming from this focus or hypocenter. Okay, so here we can see that the S wave starting from here, the P wave is starting from here. And many stations will record this earthquake shaking. Okay. And then if you want to know how to measure the magnitude, okay, this is one example. For example, if we have a primary wave, this is from the seismogram, seismic station, they has their own seismogram, and seismogram, they has their seismograph. Okay, from the seismograph, we can see the pattern of the amplitude, okay, amplitude of the earthquake shaking. So we can locate which one is the primary wave and identify the secondary wave. Okay, from the primary wave, so we have used this nomogram in order to check the magnitude of the earthquake. Okay, for example, the S, secondary wave in time minus the primary wave in time. So if we S minus P, so it is equals to 24 seconds. So in left column or left line of this graph, so you tick on the 24 second, and then on the right line, a light plot, which is in terms of amplitude. So what is the highest amplitude that producing this earthquake? So we measure from 0 to until what millimeter. So here we can say it's between 23 millimeter. So we plot on the 23 millimeter. So and then draw a line between these two results, and then we can say that the magnitude that produced by the earthquake here is 5.0 magnitude. Right? So this is only how to check and how measure the magnitude that producing by the earthquake. Am I too fast? Saya minum air sekejap ya.
Hari ni boleh minum lagi, esok dah puasa.
Itulah
Pandai Sheena dia susun. Dr. Sheena pandai dia susun sesi dia hari ni. Saya dengan Muiz kena bulan puasa.
Kenalah cepat sikit kau slow je cepat. Tapi bulan 5 banyak cuti, sebab tu kita anjak ke depan. Alright, okay. So that wave, okay, now we know that focus creates this vibration in terms of seismic wave. The wave has two types. Okay, the first one is body wave and the second one is surface wave. And the body wave also has two types. Okay, body wave is coming from the depth to the surface, okay, depth of earth to the surface. So we call it as a body wave going up. Okay, this shaking is going up, so we call it as a body wave. So the body wave is consists of two types. One is P wave. P wave is compression, means that earth is going compress and expand. Okay, so we call it as a P wave. And then S wave is that create the wavelength, okay, moving from the ground to the floor to the surface of the earth. Okay, we call it as a S wave. So the movement is like a wave, okay, wave going up. And then if the seismic wave goes up, and we create movement on the surface, right? So the surface we have two types. First one is the left wave. Okay, left wave is going there, left to right parallelly, okay, left to right. So we call it as a left wave. And relay wave, this is create a wave, okay, wave just like S wave, but this is for relay wave because it's on the surface. So we call it as a relay wave. So it's moving. We can see the pattern is moving like that. so equal as a surface wave of a Rayleigh wave. Alright. Right, so we have finished on the terminology of earthquake, seismic, the focus, the what we have. Hopefully that you can understand that what is actually produced this earthquake and shaking, and some terminology on that. Okay, now we can move to the next section, which is on the earthquake database. So we will learn it together on how to collect this earthquake database from the website. We actually can get it from the certain website. Alright, first you need to know what is types of shock. Okay, we actually have, you know, only, okay, oh, big 6 magnitude. Okay, 6 magnitude is actually the main shock. Okay, and then the shock after that we call as a aftershock. But before the main shock is smaller than the main shock, for example 3, 2. Okay, this is what we call as a before shock. So if you can see this figure, the time magnitude versus time. So if its magnitude is smaller, so it is actually called as a before shock. And then suddenly it's very big. So very big is called as a main shock. And then we can have after the main shock, the seismic wave, the vibration, the release energy that will be produced called as a aftershock. So the main shock is the largest earthquake in sequence. Before shock is an earthquake that occurs before a larger seismic event. And aftershocks are smaller earthquakes that occur following a larger event. So this is the study that done by Gardner and Noor in 1974 on how to identify what is before shock, okay, to differentiate the main shock and aftershock. Okay, for example, if we have the magnitude 2.5, so the aftershock or before shock must be in a distance of 19.5, and it should be last in 6 days. Okay, so if it's the aftershock is not between this range, means that it is no new earthquake. Means this is not aftershock. So if magnitude 2.5 must be in the limitation of 9.5 kilometer radius and within time of 6 days. And if you can see, okay, 6 magnitude, right? 6 magnitude that occurred in Ranong 2015. So we can measure actually the aftershock within 54 kilometer in radius. And we have to check the time within 510 days. It can be up 500 days for the aftershock. Yeah, after the energy released by the earthquake of 6.0. Okay, if it goes bigger earthquake, so it will has more time to settle down that energy. Okay, so this is we call as a timing, the frame of the how we measure the aftershock and before shock. Okay, this is the one example of the earthquake catalog that been collected from the website. So the earthquake catalog is contents of earthquake source parameters, date, time, coordinate, depth, and magnitude. We sample of earthquake catalog is based on the main shock. Okay, there we will limit all the before shock and after shock. Okay, in order to see the pattern of, we only see once we see the focus of the earthquake, okay, the main event. We only see interest on the main event only. So we have to eliminate the before shock and after shock. So this is some cases that been sample of earthquake between 2016 and 2020. So the magnitude is from 5.1. Okay, this is one example lah. So we have a date of the event, the time taken for the earthquake occur, and the location of the earthquake, and the depth of the earthquake. And this is moment magnitude, means that all the types of magnitude ML, MS, and MB has been converted into one moment magnitude. So we have to know how we locate the area, the site of interest of our interest study. So we have to know the latitude of and longitude of the location. And So the latitude is the measure north to south. North to south. Okay, latitude measure north and south relative to the equator poles. So on the horizontal direction, okay, latitude. This is the latitude, and the longitude is we measure on the east and west, center on the prime meridian. So this is we call as a longitude. Okay, so latitude in x axis and longitude is on the y axis. Okay. So here is 4 examples on where we can compile our earthquake. Okay, what we need to know what is the earthquake in Ranau. So we have to check and we put key in the location in terms of latitude and longitude, and then we can see the earthquake in Ranau based on this search engine. So here is you can try on the USGS website and how to find the earthquake for your area interest study area. Or you can go to the ISC website, International Seismology Center. Okay, this is being used globally, so you can pick anywhere around the world. So to check the earthquake in that region, so you can go to this website lah. And then we can also search through the global CMT. This is from the Harvard CMT catalog search. Okay. And then our Malaysia also has this earthquake catalog. You can go to the website of Malaysian Meteorological Department. Okay, this is for website that we can search around the earthquake event. And how we can search for the earthquake event? Okay, first you go to the website. Okay, the USGS, ISC, the Harvard, and MMD website. And then you have to key in the coordinate of site interest. So coordinate of site interest, latitude and longitude, and latitude and longitude. And then what date you want to know about this, the area of the earthquake. So you can just put from year 1900 until 2020. So just key in that, and then you need to enter. Okay, what are the types or the magnitude number of how big is the magnitude that you want to know. Okay, the depth of the earthquake, and then lastly you will get the output for your data earthquake event. Okay, so you go to website, key in your coordinate, set that, enter your magnitude and depth, and then you will get the output. Okay, this is some example of the coordinate. Key in the coordinate. This is for key in the magnitude, and this is the date of the earthquake event. Okay, so here is the earthquake search for earthquake events website. Okay, this is for Harvard CMT. This is for ISC, USGS, NSS, and MET, MD. Okay, but we can try first. Okay, if you have your laptop with you, I will show you slowly on how we search on the earthquake event. Okay, for example, we have these cases of Sabah. Okay, I just use Sabah because this is my area of study. Right, so the date we put as 1st of January in 2020 until 12th of April 2021. So means today lah. So we search on the earthquake activity between these between this range of dates, and we set the coordinate. Okay, coordinate is actually the area that you want to see. Okay, for example, here Sabah kan. So the latitude is on the y-axis. Latitude is on the x-axis. So x-axis is actually from 4 to 8 degrees from the map. Okay, so 4 to 8 degrees of latitude, and longitude is from the y direction. Okay, y direction is between 115 to 120 longitude. So we set the magnitude is from 2 to 7 magnitude. Alright. Okay, so we go to Harvard first. Okay. Lebih baik saya share dekat korang ni. Alright. Okay, so saya share one people here. Okay, you can click on that website. Okay, so if you click on that website, so you will come out something like this. Okay, Global CMT Search Catalog. So starting date, okay, dia catalog start in 1976. Okay, alright. So you need to key in the starting date. Okay, starting date here. You can see this box. Okay, starting dates. So you put the year is 2000. Okay, the month is January. Day is 1st. And then ending date, you have to click that like that. Previously it's put lah here, but you need to click on here. So the ending date will be 2020, which is today. The month is 12. Okay. Right. So it's good that all the undergrad students buat sama-sama lah. Okay, we work together on this. And then this is for the magnitude constraints. Okay, we have many types of magnitude here, right? So, but we only interest on the moment magnitude. So you can put the magnitude I asked you to do is from magnitude 2, okay, until magnitude 7. And then the location. Okay, location constraint is the area of your site interest. Okay, what is the latitude from? Means that the left hand side of the latitude, which is 4. And then, this is 4. Okay, go above 4 in y direction. Okay, y direction is latitude 4 is below latitude, and the top latitude is 8. And the x direction is the longitude. Okay, we put as a 115 to 120. Okay. So source time constraint. Okay, so this is just nothing. So just ignore that. So here output type you can put as a standard list of event, GMT, GMT, CMT solution format. Okay, or full format. So you just can click one of them. For example, we put here as a full format. Okay, so click done. Alright, so it will give you the result on your site of interest. So this is the data that we have been key in. Okay, the latitude, the depth, the longitude, the magnitude. And then it will give you the data for the earthquake event that for your site of interest. Okay, for example, here, region name Palawan Sulawesi. So it's the latitude longitude that we choose has been terkena dekat ni lah, Palawan and Philippines. It's included in that area of your site interest. So here is the event name, the information of data, timing, location, and because we choose the full format, so it will come out something like this lah. So it actually we can actually see the fault types. Okay, in the we call this as a beach ball or focal mechanism. We can actually know what types of fault that producing this earthquake. Okay, so from here, okay, so here we have the time of the event, okay, the location of the event, and the depth of the event, and the type of magnitude. Okay, so no MW, so it is MB and MS, so magnitude of MB and magnitude of MS. So here we can say that the magnitude is 5.2 MB or 4.8 MS. And it will list down all the events in your site of interest, for the any Borneo. Right, Sulu, You can check. It will actually more solutions means that they have many earthquake event. So you have to click on more solution until it finish. Right. Okay. Harap kamu dah dapat lah. Okay, so we try on the next one, which is ISC. Okay, this is the second website. You can actually this four website is coming from different company. Okay, so you can choose either one or you can choose all of them in order to check the earthquake for your site of interest. Okay, so I'll put the next website search of the earthquake. Okay, so you just go here and paste on the web search column. Right, not connect. Oh, probably there's an error. Okay. Okay, you guys with me or my connection is okay? Not okay? Hello? Hello?
Okay, doctor.
Alright. Oh, saya takut I cannot enter to this website. Let me check ya. Okay, the server are down. Yes, the server are down now. Okay, feel bad for it, but it's okay. We will try on the next website. Okay, USGS. Okay, most of people will go to this USGS. Okay, commonly for researchers we go search the earthquake event on the USGS website. So if you enter this website, I will share with you. So if you go to this website, you will appear like this. Okay, search earthquake catalog. This is USGS. Science for earthquake hazard program. Okay, below that you can see the what magnitude you want to for your site of interest. Okay, we put the magnitude that we select is from 2. Okay, this is minimum and the maximum is 7. Right, and then the date and time you can, because we need area of date, okay, our own date. So we put starting date is 2000, 1st January of 2000, and then we'll end today. Okay, and here geographic region is the site of your site of interest for your study. Okay, this is nothing. So so just ignore that. You just put custom and geographic region. Okay, his has been put in north and south is latitude and west to east the longitude. So north is the top of the latitude, which is 8. The south is 4. And the west is 115 to 120 degrees. Degrees. Okay, and then the depth you can set whatever you want, but I will just put 0 to 1000. Okay, and off this advanced option, we go down and event types, you just click on earthquake because here website you can actually see other types of shaking. You can say collapse, explosion, landslide. So any type of other event you can actually find from this website. But we only interest on the earthquake, so click on the earthquake. And then impact any, okay, no need to change anything. The catalogs, any, the contributor, any, and the product type, any. All right. So the output option, you can Excel file. If we click on the map, okay, map and list. Okay, it depends on what Excel file, so it's click CSV. But you want to see if it's being plotted on the map, so just click on the map and list. And the order, okay, you want it's sorted to you from time, the newest first or the oldest first, or in terms of the magnitude, largest to smallest. So we just click on the oldest first time. Okay, it's up to you want to which option that you want to set. Okay, and then click search. Alright, now we have the earthquake seismicity around Sabah region. So we can say because it's 2 to 7 earthquake magnitude, so we have it has been plotted to you directly from the site of interest of your study. So we have many earthquake happen in Sabah area. So this is one example. You can download. Okay, this is been listed for you the magnitude. Okay, from 2002. Okay, the oldest date until the newest date. Okay, we check if whether we have new latest earthquake happened in Sabah. Okay, no. So 2021 there's no earthquake yet. So but we received the biggest the recent one in Kudat. Okay, around Kudat, which is 4.9 magnitude. So you can download, click download, and then it will give you the data in terms of the Excel file. Okay. So here you can see the depth of the earthquake. Okay, you need depth of earthquake lah. Okay, here is what we happened in 2015. Okay, in Ranau, so 6 magnitude. The depth of focus of hypocenter is 10 kilometers. Alright. Okay, and then the last website is our Malaysian website, Malaysian Meteorological Department. Okay, you can go to this website. And then paste to your search engine. Okay, so it will come out something like this. Okay, but for this website, it only has I think probably 5 years of data. Means the previous year of data you need to ask permission for MMD to get the data. So what we have now is just the most recent earthquake activity. It's actually we cannot download it, but you need to check one by one the earthquake that happened in our area. Okay, you need to check, okay, whether here is our site of interest. Okay, no, macam tu lah. Okay, so we just can check it manually, or you can check the location of the earthquake from this website. Okay, because most of the global earthquake catalog, we didn't get the data for magnitude lower than 3. Okay, because we need that information, okay, to see the earthquake activity around the fault line of Sabah, so that we need to actually look into our local website. Okay, this is has been recorded by our own seismic station. Okay, hopefully you can follow. Boleh bahkan? Alright. Kita tak boleh next ya. Okay. Alright. So we have finished on the how we search for the earthquake database. Okay. So the second section is finished. And then we will go to the last section, which is introduction to the Malaysia Annex. So what is a hazard map? So hazard map is Malaysia Annex lah. Okay, the hazard map show the distribution of earthquake shaking levels that have certain probability. And this is to provide the most accurate and detailed information possible to assist engineers in designing buildings, bridges, highways, and utilities that this building can sustain the shaking from the earthquake. And to create and update the building codes that are now used by cities, countries, and local government to help establish construction requirements necessary to preserve public safety. So we need to have the data, our local data, so that we can design our building based on the hazard map. So for the building that needs earthquake design, so you have to depends on this Malaysia National Annex. Okay, so in this is a general overview on how we actually produce the seismic hazard map. Okay, in the seismic hazard map is actually can be produced either two types of methodology, which is the first one is on the deterministic, and the second one is the probabilistic. Okay, for the deterministic, if we have the earthquake happen now, so we need to know what is the PGA level for that location. So we use the deterministic. So deterministic is much simpler in order to get the PGA. Okay, only one event saja, one event only, so we can have the PGA level. Alright, and probabilistic, it consists of a long range of data. So we need the data, the pattern of earthquake seismicity, the fault line, the fault parameters, okay, all the so it takes a longer time in order to produce the PGA using the probabilistic analysis. So if we see on the deterministic analysis, okay, we have fault line, right, tadi, fault line. So we have to know how far is our site to this fault line. Okay, for example, 10 kilometers. So this is your sources distance from your site to the fault rupture. So it is 10 kilometer distance. And then you select, okay, what is the magnitude on that area? Okay, this is being recorded by seismic station. So you can say that magnitude, 6 magnitude. So you can say that the source is producing 6 perform the ground motion estimation. Plot on the acceleration into the graph and then see the suitable ground motion models that can estimate the PGA value of the site of interest. And then you can check all the earthquake pattern, okay, set and check the what is the biggest PGA produced by all this earthquake. Okay, and then that will be the result for the peak ground acceleration. Actually, more simple one. And if you go to the probabilistic, you need to have the complete data catalog. Okay, this is what we learned just now. Okay, we collect all the data. Okay, we eliminate the aftershock and the before shock. Okay, and then we identified which is the fault line that creates this earthquake. So we need to have the characteristic of this fault line. Okay, whether it's deep slip, normal fault, reverse fault, or strike slip fault. Okay, we have to identify based on that. Okay, so this figure shows you the step 1 until 4 in order to get the PGA value for your site of interest. And then you have to, after you know the database of earthquake, the fault parameters, and then you are able to plot the recurrence rate, okay? How much earthquake has been produced by this earthquake from the range year 1900 until now. So we can see the pattern. This is the parameter that we need to be included in our probabilistic analysis, combining the magnitude and the distance of fault. And then you have to estimate the ground motion parameter side. Okay, for this is based on the logic tree. Okay, you have the ground motion model, parameters of the moment magnitude, the site area, and the soil types of below the ground. So you just plot the graph in terms of estimate ground motion parameters. And then you will able to, after you analyze all the data, combining all the data in terms of probabilistic analysis, so lastly you will get the integrated hazard probability from all sources considered. Okay, so this is for probability is for 1 point. Okay, we have to check for every, for example, satu Sabah tu, you have to check all the PGA level for whole area of Sabah. So 1 point for other points, so could be 1,000, 2,000 of data. And then we will get this state hazard map lastly. Stop. Okay. So here is actually what we have gone through in order to produce the Malaysia Annex. This is done by the local expertise, the head of JKR, the head of JMG. We are sitting together and discuss on the earthquake, the data. Professor Felix also there as a advisor, also Prof Azlan, an expert in structural earthquake. And for example, yang pakai tudung is P, sitting beside Prof Azlan. And we have been done several series of meetings, joining together from Peninsula Sarawak, coming together and discuss on producing destination annex, and we have managed to publish in Malaysia in 1 year, okay, from 2016 and 2017. But this standard will be revised within every 5 years. So probably by this year it will revise again. If it's a change, so we need to publish a new map. And then if it's no changes, so we have to check the parameters which one that we need to improve, something like that. Okay. And then this is being officially launched in 2017. I was there, and then realized this is our Ketua Menteri Sabah, Habib Haji. That's previously from the Kementerian Kerajaan Tempatan. So he is actually receiving the standards from SIRIM that being officially launched in 2017. So this is our book of Malaysian standard. Okay, so this is having been compiled from all 3 areas. Okay, wilayah Sabah, wilayah Sarawak, and wilayah Semenanjung. So all engineers have to design based on this national annex. So inside the national annex, we can actually see the contour map in terms of PGA, okay, percent of G with a 10% probability of accident. Okay, for a normal building, we usually see on in case of critical fall, all of this should not be 10% probability of accident. So these types of synthesis structure must be done completed study and produce their own probability of accident for 2%. Okay, this is not for suitable for sensitive structure, but 2% for in case for the sensitive structure such as nuclear power plant, dam, hydroelectricity. So here been developed for 3 regions, which is Sabah, Sarawak, and Peninsular Malaysia. Okay. Alright, so we need to know why we have to see the PGA value. If imagine that we have earthquake. Okay, earthquake below the fault line, and then it's released its energy in terms of seismic wave. And you can see that the close structure to the we moving away with some damage to this building, but for this building, it appears no damage because it's located as far away from its earthquake source, right? So means that the close building to the active seismicity must design their buildings to include the seismic loop in order to sustain the earthquake. Okay, and then we can save cost actually for this building, for example. So we can reduce the number of steel, okay, for this building. So it's a safe cost. It's actually not all the area we covered. Oh, whole area is said that all area need to have the seismic load. No, that's why we need to refer the PGA maps whether we need the seismic loads or not. Okay, some area probably no, not require the seismic load, but some area really need that seismic load. So how big is the impact of the loads carrying by the buildings? So you need to have the value of the PGA. Okay. The PGA is the system in order to check the seismicity to sustain. Okay, the building can sustain the seismic loads. Okay, what is saya cakap PGA. Okay, what is peak ground acceleration? So the PGA is peak ground acceleration. Then this is the equal to the maximum ground acceleration that occur. Okay, we use the acceleration. Okay, not displacement, not velocity. And then acceleration is how much the velocity changes in a unit of time. And then during earthquake, when the ground is shaking, it experience acceleration. So accelerate, okay, the ground motion is the terminology that for our earthquake engineering, we use the parameter in terms of peak ground acceleration. And usually has their own units, okay, percent of G. Okay, we use the map is actually based on the percent of G. So G is the acceleration of gravity in decimal or percentage or in meter per second square. Acceleration is meter per second square. So it is equals to 1G equals to 9.85 meter per second square. This is actually 1G is actually equals to 9.81 meter per second square. So it's a gravitational unit. Okay, when there is an earthquake, the forces caused by the shaking measured as a percentage of gravity or percent of G. And then we have 10% probability of accident, 2% probability. What is this? So this is referred to the probability that a certain value will be exceed in predefined future time period. So 10% will be exceed. So means this building 10% will be exceeds its seismic loading. But 2% or in case of seismic structure, 2% will be exceeds. Means that 98% that loads will not be exceeded. Okay. Oops. So we can we do some exercise. Okay, let's try. This is a map of Malaysia region, Kota Kinabalu, Sabah region. So this map of Malaysia Annex, we have 50-year return period of 10% probability of accidents. No unit of for Kota Kinabalu city. So where is Kota Kinabalu? So it's here. Right. So here is 2, right? This is based on the contour. So we have this 2, and then this line is actually 3, and this line is 4, and this line is 5, until 6, 7, 8, 9, and until 16. Okay, 16 in Ranau is 16% of G. It is because it's active, okay, in that area. And Kota Kinabalu is here. All right. So how much is the PGA for Kota Kinabalu area? Student tolong jawab. UMS students?
3.
Okay, who can answer this? What is the value of PGA for Kota Kinabalu?
3, Doctor.
Because it's in the center. Okay, 3 is okay.
3.5.
Can be. Alright, can be. Okay, 3.5. Okay, so you can choose the PGA value. Okay, thank you for those answering the question. So it is between, so you can put the PGA value is between 3 to 4% of G. So you can take as a 3.5 3.2, 3.8. Right? Okay. So the peak restoration that has 10% chance of being exceeded in 50 years has a value between 3 to 4% of G. Alright, so actually we almost finished. Hopefully tak cepat sangat lah. Alright, so here is actually summarize, okay, what we know today's lecture. And if you see that 1A, 1B, 1C, 1D is actually what we have learned for today, okay? Actually that what I explained from the fault, the earthquake data until the Malaysian Annex, this is actually the step in probabilistic analysis. Okay, one common step in probabilistic analysis. So we have to know the earthquake source. Okay, 1A. So for example, here red line, okay, the star one is the focus of earthquake. So we need to identify the earthquake source identification, location, geometry, and mechanism of fault. And then earthquake source characterization, okay, you need to check the occurrence frequency, the slip rate, the maximum magnitude. And then check for the GMM selection. Okay, GMP is the all definition to select or create this equation to get the mean value of PGA. And then you will get the hazard calculation based on the written period, or you can use the software of OpenQuake. Okay, OpenQuake is actually the latest software for the probability seismic hazard analysis, and you're able to get the peak loss and response spectra. Okay, after you combine all these three probabilistic seismic hazard analysis in PSHA, then you can actually develop your own time history based on the probabilistic analysis. You can get the aggregation in terms of magnitude and R. The aggregation is actually we can see what is the closest earthquake sources as well as what is the highest magnitude to our site of interest. And then you can do the selection of time history and spectral matching. And then from here you can do the seismic ground response analysis. Okay, this will be covered on the chapter section 3 by Dr. Iwan and Dr. Technologies Muiz. Okay. And then we also can go to the dynamic soil structure interaction, building model, soil consistency model, and interface boundary. So all of this on the surface after we get all the data below here. So the advanced geotechnical engineering is covered all of this range of studies. So involve probability, seismic hazard, time history development, the seismic response ground motion, and also soil foundation structure interaction. Right? So you can refer some of the good references. This is what I refer and learn about the earthquake engineering, seismology, and also structural earthquake engineering. So this is 3 good references for this seismology and earthquake engineering. Okay, one is from Anil Chopra on the book of Dynamic of Structures. And this is Steven L. Kramer. There are no latest version by the Steven L. Kramer, but this is actually a good book, okay, starting from the seismological until the structural engineering analysis. So it's, all the explanation in this book. And then this is by Amir S. El Nashai. So this is during my master degree. I refer to this book on the fundamentals of earthquake engineering. Alright, so that's all for the lecture today. Thank you very much for listening to my lecture. Okay, everyone.